Anyway, we are going to start the class. Let them join. Okay. Yes. So in the previous class, we discussed about the introduction to these welded joints. In that, first we have seen what is the definition for a welding, and then we have seen what are different types of welding processes. Then after that, we discussed about different types of welded joints also. Then we consider design of those welded joints also. Basically, or broadly, the welded joints are classified into two categories. They are lap or fillet joint. Another one is the butt joint. Again, in lap joint, you have different types of joints. That is transverse fillet joint or a parallel fillet joint. Whereas in case of butt joint, you have different types of butt joints. So depending upon how you are beveling the edges of the plates to be joined, you may have single square butt joint or V butt joint, or maybe single V, double V, single U, double U, or sometimes you may have J kind of joints also there. So whatever it may be, so whether it is single or double, so based on that we need to consider our design equation. We need to modify our design equations in according to calculate the load carrying capacity of the joint. So after that we have seen the design of a butt joint. So I think we already discussed this one also. Anyway, we'll go again. The butt joints are generally designed for either tensile load or compression load. In most of the cases, they may subjected to the tensile load, so that's why they are designed for tension. So here you can see this in this diagram. You can see that you have this is a V joint or single V type, and this is a double V type. So butt joint, both are butt joints only. So now if I estimate if it is the joint is subjected to a load P, then I can calculate what is the stress. So here the design in the sense you may have two kinds of problems. Like in the beginning we discussed one kind of problem is whether you need to identify what are the dimensions of this weld. So if that is the question, then we'll call it a design problem. Or else they'll give the dimension to you and ask you calculate what is the load carrying capacity of this joint. So that is some kind of analysis problem. So you may encounter any one of those two kinds of problems, whether it may be a design problem or it may be a analysis problem. Okay, right. So here if I take this one, a single V butt joint. So here first if I want to analyze the design problem, or if I want to take up the design problem here, suppose if the joint is subjected to a tensile force of P, then how I can estimate the dimensions of this throat thickness. So here this one what we call it as a throat thickness, which is denoted by T. I want to identify what is this value, or else how much length of the weld I need to done so that this weld can carry this load safely. So for that, what we have to do is, because of this applied force, we need to estimate what is the induced stress in this weld. So we know stress is nothing but load by area. So your sigma is, because it is a normal force, so you will induce a normal stress. So we'll denote the normal stress by sigma. Because it is a tension, we'll denote it by T. So sigma T is nothing but the induced tensile stress in this weld, which is nothing but your applied load P divided by area. Our formula is P divided by area is nothing but the normal stress. So what is area here? If I take the thickness of the throat is T, and if I take the length of the L is length of the weld as L, then our area should be L into T only. LT. So using this I can calculate sigma T. So that means, so this is the formula to estimate what is the induced stress in this weld. Sigma T is equal to P by A. A is nothing but L into T. So now if I want to design this problem, then what I have to do is I need to take that and I need to take the sigma T value expression or whatever may be P by LT, and I need to equate that one to the sigma allowable. So therefore your P by LT is equal to your allowable stress, sigma allowable. So this sigma allowable may be your SUT by Fs or SYD by Fs, depending upon the type of material you are using. So Now here I can have two different kind of problems. They make you this value, that is sigma ut by sigma allowable, is given to you and ask you calculate any one of these two dimensions. That means they may ask you find out what is the t value or what is the L value required. Any one, not both, any one. So they'll give, in that case they'll give sigma t value, p value, and any one of these two. Let us say L will be given and ask you calculate what is t. That is a design problem. Or else they may give sigma this value, sigma allowable value, p value, and then t value is given, ask you calculate what is the L value. So that is what we can call it as a design problem. Or if I want to go for the analysis problem, then what they will do is they'll give these dimensions already. L and t is given to you and sigma allowable is also given to you. Ask you calculate what is the allowable load that joint can withstand, or what is the maximum load that joint can withstand. Like that they may ask. So that kind of problem also you can solve it. But either way, whether you are doing it as an analysis problem or design problem, the equations are going to be same. Only thing is, if we estimate based on these equations, if we estimate the dimensions, then we'll call it as a design problem. Otherwise, we'll call it as a analysis problem. That you need to remember. So similarly, you can do this for this one also. Here, the area is nothing but here you have two thicknesses, T1 plus T2. In place of T, you have to take T1 plus T2. That's it. L into T1 plus T2. Here the formula, again everything is going to be remain same. So that's what I think we discussed here. Okay, so then, the your joint should be safe. Your sigma T should be less than allowable tensile stress. So for a double V butt joint, the throat area you have to take it as T1 plus T2 into L. That is the only thing here. Sometimes, in most of the cases, this T1 is also equal to T2. They will take, which is then in that case it will become only 2t. So T1 plus T2 is nothing but 2t it will become. So you can solve the problem. So the thing here is, one more thing here is, suppose if you don't know all these things also, if you refer your data book, so in the data book also these formulas are given. So that's why, even though we discussed these things in the yesterday's class or maybe the previous class, still I have again considered why, because I want to show you all these formulas where in your data book where these are available. So then how you can use those things also. So now from that I'll come out of this presentation mode. Okay, if you have data book with you, just open the data book. In that you need to open the chapter corresponding to the welded joints. So if you have a data book, then open that. So in my data book, or maybe this is the old version, that's why I am specifying the page number in my data book. So you select accordingly in your. So it is 10.6 in my data book. Chapter number 10 is for welded joints. Maybe it may be different for you because your version is different from my edition, what I am using. So here in that, if you go for that 6th page, whatever unit you are taking, if you go for 6th page, see, you can see all the diagrams and all the formulas for welded calculation of the stresses in case of welded joints. So I'll show it to you. Maybe you can see that. So in this data book, so this is just after this page. If you take this, you have welded symbols is there in this page. Next to this page where you have welded symbols. So why I have shown this page is sometimes in the examination you have in semester you have a 2-mark questions also there. So in those 2-mark questions, people may ask, sometimes they will draw welding symbols or something like this. So don't say that is not there in our syllabus or something like this. You can make use of the data book. From the data book, simply you can copy the answers. Just whatever welded symbols are there. So why I am saying all these things is because you are designing a welded joint means you should know everything with respect to that welded joints. So why that is not included in this in the syllabus of this course? Because you already done these things in earlier courses. Maybe in CMDB you might have done this one, or maybe in the other case other subject maybe you might have studied about all these things. So that's why that is not included in the syllabus of this subject. But if it comes in the examination, you need to answer it. Don't say that this is out of question or something like that. So you don't have a right to claim that one is going to be the out of syllabus. So for that, so your data book may help you in somewhat it may help you. So So they given the, sometimes they will ask the symbols or sometimes they will ask draw the joint also. So everything is available here in this. So if you refer the data book, so everything, all the formulas or everything is going to be there. Anyway, this is corresponding to the eccentric load. So this we'll discuss in the later. So this is the starting point for our welded joints. So it is listed as chapter number 10 here. So you go through the terminology what he has given here. So wherever they appear, so if you don't know what is the notation for that particular one, then you can refer this table also. Okay. So now I will move on to this page. So this is page number 10.6 in my book. Maybe it may be different from your book. So here I think is it clearly visible to everybody? You can see that just now what we discussed, the formula, the case is corresponding to this one. We discussed about butt joint. So here it is single V butt joint and this is the double V butt joint. So he has given that it is subjected to tensile loads also. You can see the diagram here, it is subjected to tensile loads. So these two are corresponding to the tensile loads. Then after that you have T joints are there. So also they are subjected to some T joints, they are shown it as a force, some T joint here it is a movement. So like that. So always it need not be only the tensile force, the joint may subject it to bending moment also. If it is, we have shown arrow upward and we are showing bending, M means here, about this vertical axis, it is subjected to bending moment. Like that, you need to understand or you need to read the figure. So here, about this axis, if we say it is force means along this axis, it is subjected to force. So coming to this one now, so if you look at on the bottom here, you can see that he has given the notations and you are given the all the things. What is the notation he is using? So in our book, in our presentation, what I have shown to you, I use that T. So here he is not using the T. He is using that symbol as for H. So you can see that here in the bottom here in that description he has given, whatever he has given, sigma is normal stress and tau is shear stress, M is bending moment, MT or MB is bending moment and MT is the twisting moment and P is the externally applied load, L is linear distance, H is size of the weld, L is length of the weld. So you have capital L is there and small L is there. Capital L is used for the linear distance, small L is used for the length of the weld. So now if I come to the, if I know the terminology now, if I come to this picture here, so this is our single V butt joint. So in that below the picture he has given the formula for sigma also. Sigma is equal to P by HL. But we are taking it as TL. So here he has taken P as the T is replaced by H. So that's what he has given in the description also. In the bottom he has given what are these parameters. What is sigma, what is L, what is H, what is P also he has given. Okay. So so with this you can use all the formulas. You can use all the formulas. So directly you can use the data book to solve the problems. Okay. So then this one is going to be double B butt joint. So for that also he has given the formula. So like that you can refer the data book. With the data book you can take up all the problems, all the things you can calculate it. So but only thing is you should know, you should have a data book with you. Okay. So without data book you cannot solve anything. So that is why I'm showing all these things. So whether you have a data book with you or not, I don't know. Maybe some people are leaving the class, like our Shiv Prasad, roll number 13. Why he left the class, I don't know. So just he is attending and he is taking the attendance and then he is leaving. Like that I can understand. So similarly, what happened to this? One more person is leaving in between. So I am observing all those things. So who is joining and who is leaving the class also. So just they will attend for the sake of only attendance. They will log in and they will give the attendance and they will leave like that. Huh? Right? Okay. So I'll move to the presentation again. Okay, so this is how, like this you can have formulas for the other kind of joints also in the data book. So now I'm not going to show you all the formulas, whatever we are discussing here, they are available in the data book. So if you want to solve the problem, only thing is you need to pick the suitable formula from the data book and you need to apply that one to the given problem. That is the only thing you need to follow. So then after that we are taken up design of the transverse fillet joint. So here these transverse fillet joints are also designed for the tensile strength. So the strength calculations, the section of fillet is assumed to be a right angle triangle. This is what we already discussed in the previous class, with hypotenuse making equal angles with the two sides. So in case of right angle, one angle will be 90 degrees, but other two angles also we are taking it as equal. So therefore they are 90 by 2, which is nothing but 45 degrees. So you can see that here. So this angle is 45 degrees. Even this angle is also 45 degrees. That's what the meaning of this one. The hypotenuse making equal angles with the two sides. So this is the hypotenuse. This is making equal angle with this side as well as with this side. So that means this angle is 45. Even this angle is 45. Obviously, this is going to be 90 degrees. So now, so for this case, if I want to estimate what is the stress induced because of this applied force P, here you have two types of things. One is single transverse weld. Other one is double transverse. So that means if the weld is done on the two locations at the two edges. This is one edge of this is the edge of this bottom plate, and this is the edge of the top plate. So if the welding is done at the two edges or edges of the two plates, we call it as a double transverse. Here it is only you have a weld at only one location, that is at this at the top. You don't have weld here at the bottom. So therefore that's why here you can see that from looking at the figure also what is the terminology or what is the convention you are following here. He has shown two dotted lines here showing that there is a weld. So that means even this view is not available to you by looking at the top view. So here you can say that this is the weld, but here you are a single line means only this is the hidden line because of this edge. So therefore here you have a two hidden lines means you have a weld at this location also. So like that also you can understand. Okay. So right. So to estimate this now, like what is stated here. So we'll assume this one as a, even though here you have your weld portion is something like this. So here it is a convex shape is there. We are approximating this one as a right angle triangle only. So that means whatever left out portion is there, that will take it as a reinforcement for this joint only. So but while calculating the strength of the joint, we'll consider only the triangle. So we'll estimate the strength of the joint based on this triangle only. So then if I join this D to B here, this D to B is nothing but perpendicular to this hypotenuse. D to B is perpendicular to this hypotenuse, and this is passing through this point B. So this is going to be the line or maybe the section where the thickness of this weld is minimum. The weld thickness is minimum here. So if I take somewhere here, so if I take point something like this value is more than this only. So this length. Similarly, if I take some other point something like this, that is also more. This length is more than this one. So that means always in design problems we need to design for the minimum area. So therefore I need to take the minimum dimensions for that. So therefore we'll consider the minimum thickness. So this what we'll call it as throat thickness. We call this one as D to B. We call it as a throat thickness. So in the case of this throat thickness, so based on this throat thickness T, it denoted that one as T, and this is S. So there is definitely a relation between, from this diagram you can easily write the relation between this T and S also. What is the relation you are going to get? So this is 45 degrees. Since I said it is a perpendicular, this is 90 degrees, even this is also 45 degrees. If this is 45, this also should be 45. So then in that case, so I want to estimate this value. I know this one. This is the hypotenuse. Here you can say for this triangle, if I take this triangle, for this triangle, this is the hypotenuse and these are the two other sides. So now if I want to estimate this T value, so then what I can do is I can use your tan 45 formula. So if I take or else I can use sin 45 formula also. If I take this angle, so what is sin 45? Opposite side by hypotenuse. So your sin 45 is nothing but sin 45 degrees is equal to, so here I am taking this dimension as T. So it is T by S, where S is called, this dimension is S, even this dimension is also called S. We'll call this S is leg of the weld or size of the weld. We'll call it as either leg or size of the weld, and T we are calling it as a throat thickness. And the relation now is, if you want to calculate what is sine 45, sine 45 is 1 by root 2. If you know, so your sine 45 is nothing but 1 by root 2 only. So sine 45 is 1 by root 2 is nothing but T by S. So from this, if I want to write a relation between T and S, what I can write? Root 2T. Root 2T is equal to S. So that means this is the relation between throat thickness and the leg of the weld or size of the weld. So root 2 is nothing but 1.414. 1.414 T is equal to your S. So in most of the calculations, we'll use this relation. S is equal to 1.414 T. So I think that is given in our data book also. If you want, you can go through that also. Right, now if I want to estimate, suppose if the joint is subjected to a single transverse stress, which is a single transverse fillet weld, which is subjected to tensile load here like this, then again the induced tensile stress, that is sigma D, is nothing but load by area only. Load by area. So here the area is, I need to consider this, that minimum thing, minimum area we need to consider. So therefore T into L. Your area is again here T into L only. P by T into L. But if I consider instead of T, if I want to write that one in terms of size of the weld, so that means in terms of L, I can write this one as P by. So what is the relation between T and S? T is equal, root 2 T is equal to S. So therefore S is equal to T is equal to root S by root 2. You can take like this. So what is this root 2 R? If I bring this root 2, it will come to the numerator. Root 2 is nothing but 1.414 only. 1.414 P divided by S into L. So this is the formula for a single transverse stress. If it is double single transverse fillet weld, so if it is a double transverse, then here you will get 2 times it will going to be something like this. So that is the formula. So that is the formula for design of. This is the formula for design of this transverse fillet weld. So that's what I have shown in the slides also. Length of each side AB and BC is known as the size or leg of the weld, S, denoted by S. That we already discussed. The distance of hypotenuse from the intersection of two legs, BD, that is BD here, is known as throat thickness T. So then based on that, the minimum area is to be obtained at the throat. So that's what I said. This is the minimum value for T. So therefore we need to design the joint based on this T value. If L is the length of the weld, then throat area is going to be T into L, which is nothing but S sine 45 into L. That's what we already seen. So sine 45 is 1 by root 2, which is nothing but 0.707 SL. So then the tensile stress should be P by A, which is nothing but P by 0.707 SL, or else I can write this one as something like this also, root T by P SL also. Like this also you can write. Both are same only. You will get both are same. In case of double transverse, you will get 2 here. So it will be divided, multiplied by 2. So therefore, what you are going to is root 2 by 2. So 2 by root 2 is nothing but 1.414 only. You are going to get only this relation. So this is how we can estimate the tensile stress in a transverse fillet. Similarly, if I take a parallel fillet joint now, so if a definition for parallel fillet is the line of action of the load, applied load. So this is the line of action of the applied load. If this is parallel to the your length of the weld, this is the length of the weld and this is the length of the weld. So now these two lines are parallel. Your length of the weld and line of application of the load, they are parallel to each other. If they are parallel to each other, then I can say this is a transverse parallel fillet weld. Sorry, not transverse. It is a parallel fillet weld. So in case of parallel fillet weld, what type of stress it is going to induce? This P. Now earlier this is P. In case of this parallel transverse fillet weld, so your load is normal in the normal direction to the welds, or in the normal direction to this weld, in the sense it is a perpendicular direction. So normal means it will induce a normal stress. Normal stress. So whereas in case of this parallel fillet weld, your load is now, it will act as in a tangential direction to this weld. So therefore, this will create a shear stress in the weld. So therefore, these parallel fillet welds are designed for shear strength, not for tensile strength. So because here the load will become a tangential load to this weld, this tangential load will induce a shear stress in the weld. So therefore, parallel fillet welds are designed for the shear strength, not for the tensile strength. So now consider again the parallel fillet weld as shown in this figure. Throat area, again the throat area formula is going to be same. You have to take either T into L, or you can substitute for T is equal to 0.707 S. Either way you can do it. So T into L is the area of the weld. So then load divided by area is going to be the stress. So only thing is here it is a shear stress, but your area of weld or area resisting the given load is same. Where it is a normal stress or shear stress, it is going to be same. So therefore, the magnitude of shear stress is given by the same P by 0.707 SL. If it is a double, here I have a two welds here and both sides are there, then I need to take it as 2A. If it is only the weld is there on only one side, I will take it as only A. So in this case, it is given on both sides, so I have to take P by 2A. So that is nothing but P by 2 into 0.707 SL. So which is nothing but 1.414 SL. So like this, I can estimate the shear stress in case of a parallel fillet weld. So now next comes when, okay, so I know if the weld is a transverse fillet weld, I have a normal stress. If the weld is a parallel fillet weld, then I know that it is a shear stress. But sometimes you may have combination of both also. You have parallel fillet weld at the same time transverse fillet weld. Then in that case, how I can estimate the load carrying capacity of that particular joint? So like this. So what I showed here, now this weld and this weld will call it as a parallel fillet welds. Whereas this weld, I have to call this one as a transverse fillet weld, because this length of the weld is perpendicular to this load. So therefore, this is a transverse fillet weld. Here this weld and this weld, the length of these two welds are parallel to the applied load. I call these two as parallel fillet welds. That means here I have a combination of two parallel fillets and one transverse fillet. Sometimes you may have here at this location also you have a weld. So that is another transverse fillet weld. So that means two transverse fillets and two parallel fillets also. Like it also. Like that, you may have a combination of both transverse as well as parallel fillet welds. So in that case, how we can proceed, or how we can estimate what is the load carrying capacity of this joint. So it doesn't matter. We know right now, we know the concept. So if it is a parallel fillet weld, it is subjected to a shear stress. If it is a transverse fillet weld, we know it is subjected to a normal stress. So now, if I want to estimate how much load this joint can carry, this P value, so that is nothing but the sum of the load carried capacity of this transverse fillet welds plus the load carrying capacity of this transverse fillet weld. So for that, what I need to do is I need to estimate what is the load carrying capacity of this transverse fillet weld plus the load carrying capacity of this parallel fillet weld plus the load carrying capacity of this parallel fillet weld. It should be equal to your P. That is going to be the design equation. So now how I can calculate the load carrying capacity of this transverse fillet weld? If I know the area of this transverse fillet weld, that is nothing but again T into L. That is the area of the weld multiplied by the allowable stress. So here the transverse fillet weld is subjected to a normal tensile stress sigma T. So therefore, this is going to be the load carrying capacity of this weld. So that means since I have only one, I have to take only T into L into sigma T. Suppose if I have weld here at this location also, that means I have two welds. I need to multiply this one by 2. So therefore, this is going to be the load carrying capacity of these two transverse fillet welds. Then plus, So I need to estimate what is the load carrying capacity of this parallel fillet well as well as this parallel fillet well. If the length of these two wells is same, then similarly here what I have to do is I'll take 2 times the strength of one weld. So we know this parallel fillet weld is subjected to a shear stress. Then the area of this weld multiplied by the allowable shear stress is going to be the load carrying capacity of this one. So again we take that one as T into L is the area of the weld multiplied by tau is going to be the ever allowable stress in that joint. So therefore this should be equal to your applied load. This is going to be our equation, design equation. Suppose here I have only, in this case I have only one parallel fillet, one transverse fillet here. So then in that case I need to remove this. Then I need to write the design equation is something like this, because I have only one transverse fillet. If I have one more here, then I will multiply by 2. So then afterwards, if you want to substitute for this T, if you want to write this one in terms of throat thickness, if I want to write the equation in terms of leg of the weld, that is S. So we know the relation between S and T. S is nothing but root 2T. S is equal to root 2T, or else I want to write a T in terms of S. So from this I can write S, T is equal to S by root 2. S by root 2, that is nothing but 0.707. Yes. So I'll substitute wherever T is there, I'll substitute for T as 0.707. Yes. So then that is going to be the design equation for calculating the load carrying capacity of this combined transverse and parallel fillet weld. So that's what I shown here. If a tensile load P is applied on a combination of transverse and parallel fillet weld, shear stress will develop in the parallel fillet welds, that we already know, and tensile stress will develop in the transverse fillet weld, such that the maximum load that the weld can withstand is given by your P max. So this P max is given by 1.414 S into L1 into T. L1, why I written L1 here? Because he has taken okay, maybe he has wrongly taken this is, so he assumed that here two transverse fillets are there. So then the length of this transverse fillet weld he has taken it as L1. Similarly, the length of the transverse fillet he has taken it as L2. So that's why here S into L we have written the formula there, but here S into L1 is nothing but L1 is the length of the transverse fillet weld and L2 is the length of the parallel weld. So why I am getting here 1.414 and 1.414 is because I have two transverse fillet weld and two parallel fillet welds like this. So in that case I can calculate this is the maximum load. So then based on that I can estimate, or else what I do is they will give you the allowable load, or they will give you what is the load the joint is subjected to. From that ask us calculate any one of these parameters, L1 or L2 or maybe S. Like that they may ask a question. Okay, where L1 and L2 are the weld lengths on two sides. Okay, as shown in the figure. While designing any fillet weld, okay, this is one more important point, especially in design point of view, 11.5 mm length must be left on each side of the weld to allow for the start and stop of the bead. So what is the meaning of the statement here? See, if you want to do the welding, so I think you know how welding is going to be done. So you need to run the welding gun in the direction of the weld. Suppose if I want to weld in this direction, so I need to run the weld gun in this direction. So here this is the start of the weld and this is the end of the weld. Actually our requirement. So our weld should be, or I need to weld from this location to this location in this direction. But practically it is impossible exactly I have to start from this point and I have to end this point, because so welding gun is moving with some velocity. So if it is moving with some velocity, say instantaneously I cannot point this point here. So and similarly I cannot stop exactly here. The weld gun is moving with some velocity here. I cannot make it zero exactly after reaching this point. So therefore, to allow that, what they will do is they will take this 11.5 mm length on either side to be left on each side of the weld to allow for start and stop of the bead. So that means generally, even though if I say the weld is something from starting from here and ending from here, so you need to consider the weld length is this side 11.5 mm and this side also 11.5 mm. So that means if I want to estimate the total length of the weld required, I need to take this is the total length. So in that case, it is going to be your L2 plus 22 mm, 23 mm, not 22, 11.5 into 2, it is 23 mm. But while calculating the strength of the weld or while designing that, we'll take only this one as the weld length. So only L2 will consider while calculating the dimensions. But after calculating that, suppose if they ask what is the L1, what is the L2 required. So then from the calculation, let us say you got L2 is equal to some 50 mm, let us say. Then the length of the weld required is, you need to add this 23 also for this. You need to state that length of the weld required is 50 plus 23, which is nothing but 73. In that, out of 73, the 23 is allowed, or we can say it is a allowance on the weld. So to provide start and stop of the braid. So like that you need to estimate. So therefore, this is also one important point. Only this is for fillet weld, not for the what you can say lap weld. So this is only for lap joint. So it's not for the butt joint. In case of butt joint, you don't have that type of option also. So butt joint means you are placing the plate side by side. You cannot overrun or you cannot start before. So that kind of option is not available in case of butt joints. Only in case of fillet joints only you need to provide this additional length to the weld joint. Okay. So this is how you can find the strength of the joint when you have a combination of parallel and transverse fillet welds. Then you may have unsymmetrical weld sections also, something like this. Here what I showed in this diagram, here this weld length is different and this weld length is different here. So now, because if I apply a force here, what happens here, because of, so the length is different, just now we computed. So this is a parallel fillet weld, we know. So from the point of application of this load, we can easily say that these are the parallel fillet welds. So the strength of the parallel fillet weld is nothing but area of the parallel fillet weld. That is here, if I take this one is LA, this length is LA, and this length is LB. So then, if I want to calculate the length strength of this weld, that is LA into T or 0.707 AS, I can take into tau. So this is the allowable strength. So let us say it is P1. So P1 is going to be the PA. P1 is going to be the LA into T into tau, strength of the joint. Then here, if I calculate this one, it is LB into T into tau. This is strength of the bottom joint. Let us say it is P2. So now these two are not equal. Why? Because these two are not equal, because your LA is not equal to LB here. So LA is smaller than LB here. So in that case, your P1 is less than P2. P1 is less than P2. That means the load carrying capacity of this joint is small or less than compared to this joint. So then what happens if the load carrying capacities are different? So let us say it is taking a load of P1 and this joint is taking a load of P2. Or else, okay, if I apply force here, the reaction is going to be in opposite direction. I'll consider in the opposite direction. So here the load taken by this one is P1 and the load taken by this joint is P2, but these two are not equal. So since these two are not equal, then what happens is, so if I take about the center point here, so there exists some bending moment is there in this. So because if these two are equal about the CG of the weld, if I take that, the distance is going to be same. This distance is same and this distance is same. If because of this P2 you have a movement in this direction, that is clockwise direction. Because of this P1 you have a movement something like this, anti-clockwise direction. So now this distance is, we take total distance is something like equal. In that case, what happens is P1 into L by 2 or P2 into L by 2. If P1 and P2 are equal, then this moment is equal to 0. Because this force is same and this force is same and they are acting at a same eccentricity, the net moment is going to be 0. But that is not the case here, where P1 is less than P2. So therefore, if P1 is less than P2, then what happens is there is a net movement acting on this weld joint. So in order to eliminate that one, that means in addition to this applied force here, this movement will create additional stress in the weld. So that means which will decrease the strength of the weld. So in order to decrease that or in order to eliminate the bending moment, what they will do is they will adjust the center of gravity of the weld such that the bending moment created by these two loads taken by these two welds is going to be zero. So that means, see, you can see that now here, this is the center line of the weld. So that means the center of gravity of the weld lies on this line, which is not symmetric here. See, it is this side you have a more distance when compared to this distance. That means this this distance he has taken it as A and this distance is taken as B. So here from this diagram you can clearly observe your A is greater than B. Why? Because here this side you have a less force, this side you have a more force. So in order to equate the both the moments, that means if this load by this P, load is less, so I am increasing the wave value so that I can make it is equal to the moment created by this load. That is nothing but load acting here multiplied by this LB. So that there won't be any bending moment. That means this is create a clockwise movement and this will create an anti-clockwise movement. Both will cancel out each other. So therefore you don't have any net bending moment on the joint. So therefore the joint is subjected to only the tensile load. Or that means only tensile stress. There won't be any bending stress because the bending moment is zero. So therefore the condition for that is in case of unequal weld sections or unsymmetrical, I can call it as unsymmetrical weld sections, always the center of gravity of the weld is designed such that it should make the bending moment is equal to zero about the centroidal axis. So that's what I stated here. For an unsymmetrical weld section subjected to tensile loads as shown in figure, the length of the weld should be proportioned that okay, I think from my side there is a power failure here, so that's why I was disconnected. Again the power came now. There is still some issue with the network. Maybe internet connection is not okay. It is hanging out. So wait for. Okay, now okay, it is okay now. Okay, right. So we are discussing about this one. So we'll continue. I think till the class is in recording mode only. Okay, yeah. So it is in recording mode only. Right. So in case of unsymmetrical weld sections subjected to tensile loads, the length of the weld should be proportioned such that the resisting moment of the welds about the gravity axis is zero. That means about the centroidal axis or gravity axis should be zero, so that the bending stresses can be eliminated. Only the weld is subjected to only the weld is subjected to a normal stress. So now to identify that, so that means what is the value of, suppose if LA and LB they are fixed, or if I know this A and B, so I know the center of gravity of this weld section, then based on that how I can estimate how much the length of the weld on the top and how much length of the weld I need to consider on bottom. That means I want to estimate what is LA value and LA value, how I can derive the formulas for that. So for that the only sole criteria is you have to consider this is equal to 0. That is the moment about the central axis should be equal to 0. So then, so let us take A and B are the distances of welds from the gravity axis. Then the total length of the weld is nothing but we know. So if this is LA and this is LB, the total length is going to be LA plus LB only. And applied axial load is P only. So resistance offered by the weld per unit length, we calculated that like that, but you can calculate the load taken by the weld also, like that also you can calculate. So he has taken F is the resistance offered by the weld per unit length. That means sigma L, sigma T, so this is F is nothing but your sigma T only per unit length. So then resistance offered by the weld on side A about gravity. So just now I shown earlier already, if this one is LA, this length is LA and F is the resistance offered by this length per unit length, then LA into F is going to be the resistance offered by this weld. So that's what I showed it as a P1. So that P1 is nothing but your LA into F into moment, because I am taking moment about this axis. So this load multiplied by this A will get the moment. So therefore moment of resistance offered by the weld on this side, top side. Similarly, I can calculate moment offered by the weld from the bottom side. So that is nothing but LB into F into this B value. So for zero bending moment, so this is moment of resistance offered by the weld on side B about the gravity is LB into F into B. So for the moments about the gravity axis to be zero, these two should be equal, because this is one is clockwise moment, other one is anti-clockwise moment. So therefore, if I take algebraic sum, there should be 0. So that means clockwise moment should be equal to the anti-clockwise moment. So if I take that, since the weld is of same material, so the resistance offered per unit length I can cancel out each other. So then what I'll get is LA into A is equal to LB into B. So again, I have one more relation, that is the total length of the weld is nothing but LA plus LB. So from that equation, this is one equation, but I have two unknowns, LA and LB. Two unknowns are there with one equation. I cannot solve it. So I require the additional equation. That additional equation is nothing but this one. LA is equal to, L is the total length of the weld is equal to LA plus LB. So therefore, from this and this, I can calculate or I can derive an expression for LA and LB. So if any one of these two equations, so let us say for LA, I can substitute as L minus LB. So if I for LA, if I substitute L minus LB, and if I simplify that, from that I'll get an expression for LB. LB is nothing but LA divided by A plus B, and similarly I'll get LA is equal to LB divided by A plus B. So with these relations, so I can easily estimate how much length of the weld I can consider on the top side and the bottom side in case of this unsymmetrical weld sections. So like this you can design whether it is a transverse fillet weld or parallel fillet weld, or maybe a combination of transverse and parallel fillet weld, or you may have unsymmetrical welding sections also. Okay, so for all these things, if you refer our data book, you have all the formulas for all these things. Whatever we discussed so far, All those things are listed in the data book in that particular page what I already shown to you. So now what we'll do is, so we come to that critical discussion part of end of the critical discussion on this. So then we'll try to see some numerical problems, how I can estimate the how I can solve the problems. So maybe sometimes you may get design problems or sometimes you may get analysis problems. Whatever may be the problem, how I can solve the problems based on these concepts. So for that, we'll consider this one is our first problem. Just you note down this problem, then we'll discuss the solution also. I'll give 2 minutes time to you to note it down so that we can discuss the solution also. Just note down, then we'll discuss the solution also. You take down the fair also. So okay, no issue. You can note it down now. Once it is completed, just intimate me so that we'll discuss the solution also. A gas tank consists of a cylindrical shell of 2.5 meters. A gas tank consists of a cylindrical shell of 2.5 meter in diameter. It is enclosed by hemispherical cells by means of a butt welded joint as shown in the figure. The thickness of the cylindrical shell as well as the hemispherical cover is 12 mm. Determine the allowable internal pressure to which the tank may be subjected to if the permissible tensile stress in the weld is 85 Newton per mm square. Assume the absence of welded joint as 0.85. So you can see that here it is the tank, gas tank. So these are the hemispherical ends. So these ends are joined to this cylindrical portion through a butt joints. You have a butt joint here, you have a butt joint here. So now this tank is subjected to a internal pressure. So that means this internal pressure will create, so you might have studied about the thin cylindrical shells. So this internal pressure in this shell will create a tensile stress in these welds. It will create a tensile stress in the weld and he has given the magnitude of that allowable tensile stress, that is permissible tensile stress in the weld as 85 MPa or Newton per mm square. And also, he has considered the efficiency of the joint is only 0.85. That means the strength of the weld is not equal to the strength of the parent material. So, to accommodate that, he has taken the efficiency is only 0.85. So, and also he mentioned that what type of weld it is? It is a butt weld. So, in case of butt weld, we know what is the formula for our sigma T. Sigma T is nothing but load divided by P is the load, the joint which the joint is subjected to, and area of the L is where of the L you can take it as T into L. You can take it like this. So he has already given the T value. Thickness of the plates is T is already given as 12 mm. But only thing is we need to estimate what is L value. And he asked us calculate what is the allowable internal pressure. That means what is the maximum pressure the cylinder can withstand or the gas tank can withstand. What is this P max value? He asked us. Small p, here it is small p. So how I can estimate that? If the cylinder is subjected to internal pressure, what is the load acting, tensile load acting in the direction along the longitudinal axis? The tensile force is nothing but the magnitude of the internal force multiplied by internal pressure multiplied by the area of the cover plates, that is 5 by 4 into, if he has given the diameter as d, so the internal diameter which is d square. So this is the value. So this should be equal to your resistance offered by this weld joint. So here, since he has given that the efficiency of the weld joint is only 80%, so I need to include that efficiency term also here. So therefore, this is the formula for sigma T. So that means from this I can calculate P value. So P is equal to sigma T into eta, that is the efficiency of the joint, into T into L. What is the length of the weld here? See, you are making the weld here on the circumference here. This is a cylindrical surface. You have a cylinder something like this here. The weld is along this cylindrical surface. Here you are welding means this is the surface you are doing that. So now if I want to calculate this length, that is nothing but the circumference of this cylinder. So circumference, if D is the diameter, the circumference is nothing but pi into D only. Pi into D is nothing but your L. So in this equation, sigma T is given as 85, eta efficiency of the joint is given as 0.85. T is given as 12 mm and L we just computed based on the circumference of the cylinder, which is pi into D. D is 2.5 meters. D is 2.5 meters, that is also given. So now I can easily calculate this P value now by substituting all those values. Then I'll take this P value, whatever I got it, and I'll substitute that here. So which is equal to again Pi into 5 by 4 D square. So in this, Pi is unknown to us. 5 by 4 D is given as 2.5 meters. So, but only thing is you need to convert this one into mm. So 25,000 mm square. So then from that I can calculate this Pi value. So that's it. That is the straightforward solution. Only thing is what you have to do is you have to estimate what is the area of the weld. So once you done that, you can done with your problem also. So that's what I showed it here. So this is the given data. D is given at 2.5 mm, T is 12 mm, and sigma T is 85 mm. Efficiency is 0.85 mm. So first I'll calculate the tensile force on the plates. That is nothing but length of the weld into thickness of the weld multiplied by the allowable tensile stress. So length of the weld is taken as pi into D, which is nothing but pi into 2500, which is comes out as length of the weld as 7853.98 mm. Then load carrying capacity of the joint is nothing but P is equal to sigma T into L into eta. If I substitute the respective values, I got it as 6809.4 kilonewtons, not newtons here, it is in kilonewtons. So now I'll take this and I'll equate it to the load carried by that cell. So therefore it is 5 by 4 D square into P is equal to your load here. So since it is in kilonewtons here, I have to convert that one into newtons. I have to multiply 10 power 3. So by equating this, if I solve this equation, I'll get the maximum allowable pressure as 1.39 MPa. So like this, you can solve the problem. It is a very simple problem only. So that too on butt joint. So like this you can solve that. So sometimes if the efficiency is not given, you take a efficiency as 100% and you can solve the problem like similar manner. Okay. So I think I'll stop now today at this point. In the next class we'll consider some more problems. So and then we'll move on to the, after completing those problems, we'll move on to the eccentrically loaded welded joints also. Okay. So if you have any doubt in today's class, then you can ask now. So then everything is clear to you. Just give the attendance and you can leave the class. I think I already placed the attendance sheet. If you go through that, yes, I think already 49 members have given the attendance. Okay. So if you don't have any doubt now, then don't be in the class. Just leave the class, then give the attendance. Okay? You come out of the class. So somebody just they kept it on and then they are there forever. I have to forcefully remove them. They are not going out of the class.